Hello my dear students, I warmly welcome you to CR Digital Classes. So now from this lecture we are going to discussing last unit of solid geometry. The name of the unit is the conicoid. Okay, so in this unit the first topic is the general equation of the second degree. This is the first topic. So in this first topic today our first question is write the standard forms of the conicoid. The first conicoid is ellipsoid and the second conicoid is cone. So in this lecture we are going to discussing about these two conicoids. So first of all, before going to discuss about ellipsoid and cone, actually what is conicoid? Okay, in this unit what are the topics we are going to discussing about? So we'll discuss briefly about all those topics. Okay, so first of all, see the general information. The locus of the general equation ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy plus 2ux plus 2vy plus 2wz plus d is equal to 0. Okay. So this total equation ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy plus 2ux plus 2vy plus 2wz plus d is equal to 0. This total equation of the second degree in three variables. Three variables means x, y, z is called a conicoid or quadric. Okay. So actually conicoid is nothing but conicoid is also a surface. That surface is formed by the second degree equation. Okay. This is the main equation for each and every conicoid whatever we are going to discuss in this chapter. Okay. So from this second degree equation only we can form different 14 types okay, we have 14 types of conicoids. That means including all the planes, conicoids, ellipsoids, spheres, centroids, all the things including all the shapes. So we have 14 types of conicoids. Those all 14 types we can derive from only one equation. That equation is called second degree equation, general equation. So now this is general equation of second degree. This general equation of second degree can be reduced to any one of the conicoid. I said just now only. So any one of the conicoid means we have 14 types of the conicoids. That means including all the things. Okay. So this second degree equation can be reduced to any one of the equation by using the concept of transformation of coordinate axis. Okay. So this is the one of the very important information regarding the conicoid. Okay. So now next what they are asking, ellipsoid. Okay, our first question is, so now we are going to discussing ellipsoid, first conicoid. So ellipsoid, an ellipsoid is a surface where the sum of the coordinates each scaled by different constants is equal to 1. Okay, so you have to read this, read the definition of the ellipsoid is, the ellipsoid is a surface where the sum of the coordinates equals to 1. Okay, equals to 1, each scaled by a different constant. So that means the standard form of an ellipsoid centered at origin. Okay, centered at origin. This ellipsoid is also a three-dimensional conic section. Okay, so center at origin 0, 0, 0 with a semi-principal axis aligned with the coordinate axis. What is the meaning of semi-principal axis? Semi-principal axis means whenever you take x-axis, y-axis, z-axis, if that shape of the ellipsoid will be in this format. Okay, from the center that is origin, from origin to this point, this is called semi-principal axis. Okay, every coordinate axis is a principal axis here. Here we have three principal axes. Okay, so we can call them as a coordinate axis. So now the standard form of an ellipse centered at origin with a semi-principal axis aligned with the coordinate axis is given by this format. Okay, so that equation of the ellipsoid is x square by a square plus y square by b square plus z square by c square is equal to 1. In intermediate, you study ellipse topic, there we discussed that x square by a square plus y square by b square is equal to 1 only. Okay. So, based on this equation, in intermediate level, we discussed 4 types of ellipses. One is centered at origin and the second one is centered at h comma k. Okay. So, centered at c 0 comma 0 and centered at h comma k. So, x center at 0 comma 0, this is the ellipse equation. If center at h comma k, what is the equation? X minus h whole square by a square plus y minus k whole square by b square is equal to 1. Where also we discussed that major axis, minor axis, okay, small a and a small b. If a greater than b, small a value greater than b, then you will get this equation. If b greater than a, then you will get that same equation. But when a greater than b, the ellipse is horizontal. This is horizontal ellipse. And if b greater than a, okay, so then the ellipse is vertical. These all things we learn from intermediate mathematics, only from coordinate geometry. Saying continuation of that topic. So here we are discussing in solid geometry with a 3-dimension space. Okay, 3-dimension space, x square by a square plus y square by b square plus z square by c square is equal to 1. This equation is called ellipsoid equation. So now here, what are small a, small b, small c? A comma b comma c are the length of the semi-principal axis. Okay, so see, a comma b comma are the length of the semi-principal axis of the ellipsoid. If a is equal to b equal to c, then that ellipsoid is a sphere. Okay, so you can see the image of the ellipsoid. This is the image of the ellipsoid. Okay, so here from the center, if you take this center value as 0 comma 0, this center origin 0 comma 0 comma 0, from the center towards positive x-axis, this distance, okay, from the center towards positive x-axis, this distance is called small a, and negative x-axis also small a. Okay, so that's why we are calling a, b, c are the lengths of the semi-principal axis. Small a is the length of the semi-principal axis. That means from origin to that curve of the ellipsoid. Next to small b, you can take on y-axis. See here. So on y-axis, so this length we can call it as small b, length of the small b, and on z-axis small c. Okay, this a, b and small c, these 3 values are called length of the semi-principal axis of an ellipsoid. Okay, this is the ellipsoid diagram, 3-dimensional diagram. Here you can see in the first, this is the total outline of ellipsoid. Okay, ellipsoid from outside it is looking like this, but if you cut the inside the planes of the ellipse, they will exist in this format. This is one plane and this is one plane and this is one plane. Okay, so in this format, plane A, plane B, plane C, we have to take in this format. If you got that, means here whatever you are seeing, this only slice, that slice we can take from this region. Okay, this region, from origin to this region we can equate with this slice. Okay, so same slice మనకి ఇక్కడ కూడా exist అవుతుంది. So whatever you are seeing from O Z Y, that is a plane. Okay, we can call that plane is semi-principal plane. Okay, so like semi-principal axis, that is called semi-principal plane. So this is the ellipsoid and this is the information regarding the ellipsoid. Okay, next point is cone. Okay, so cone of the next conicoid is cone. The standard form of a cone centered at origin with its apex at 0 comma 0 comma 0 is ax square plus by square plus cz square is equal to 1. This is the equation of a cone centered at origin. Okay, where a comma b comma c are the constants. Those constants defines the cone's proportions. Okay, so actually cone, about regarding cone, so here you need to focus one more point. In second unit also we studied very well about cones only. Okay, right circular cone and their properties. Again in this chapter also we are going to learn the conditions and the proportions of the cone. Okay, but for the definition purpose, okay, for the definition purpose you have to write this much for the cone.